Ready to present notes section 9.10, more on trigonometric ratios. Today we're actually going to use the ratios to find missing parts of a triangle. If we have an angle and a side, we're going to find perhaps a missing side. If we have two sides, we could find a missing angle. We're going to attempt to solve right triangles using what we know about trigonometric ratios. Are you ready, Mr. Stern?
I'm ready.
All right. Well, before we can attempt to solve a right triangle, we first need to understand how to find the cosine, sine, and tangent of an angle. So let's take this first example, cosine of 60. Now, I think we could draw a 30, 60, 90 triangle, where this angle would be 30, this would be 60, and just for convenience sake, let's go ahead and say that the side opposite the 30 is 1. Mr. Stern, what would the side opposite the 60 be?
1 root 3.
Or we could just call that root 3. What would the hypotenuse be?
2.
1 times 2 or 2. Nice. Well, this example is asking us to find the cosine of 60. So, relative to the 60-degree angle, we have which side would be the adjacent side?
1.
So we could say that the cosine of 60 is equal to 1 over
the hypotenuse, 2.
2. So we know that the cosine of 60 is 1/2. All right, well, what happens though when we get to cosine 55? Do we know any triangle ratios that involve a 55-degree angle?
Not yet.
Not yet. So exactly, let's go ahead and use our calculator to approximate these ratios. Cosine of 55. So start out, let's make sure your calculator is in the correct mode. Now for a scientific calculator you want it to say perhaps DEG or DRG in the window. It just depends on the brand. For a graphing calculator you need to hit mode and then make sure that we have degrees highlighted. Go ahead and just enter cosine, and then we're using 55 and enter. Now what we just generated is a decimal equivalent of the ratio of the opposites, of the
adjacent to hypotenuse.
You're right, Mr. Stern. Thanks for jumping in. I could not stop stumbling over my words. We just generated the decimal equivalent to the ratio of the adjacent side to the hypotenuse for a 55-degree angle. What we want to do then is round this off. Let's choose,
let's go with the hundredth.
You go with hundredths? Okay. I was going to say thousands, but either one is fine. 0.57. So what your calculator has done, it has memorized all possible decimal equivalent ratios for all possible acute angles of a right triangle. Pretty awesome, huh?
It's terrific.
Yeah, what a great tool. All right, let's go ahead and finish this up. Let's enter tan 35. What do you think, Mr. Stern?
0.70.
You are correct. And sine 42?
0.67.
Perfect. Now, all the ones in this column had you just enter the trig function and the angle to find the trig ratio of the angle. Now we're going to work backwards. Now we know the ratios, and we're going to work backwards to find the angles. So how we do this is we use the function on your calculator called inverse trig. And now a lot of calculators make you hit the second button before you hit the particular trig button you're interested in. So if I wanted to find the inverse cosine, I would press second and then cosine, and up would pop a cosine -1 into the window of your calculator. So if I know that the cosine of an angle is equal to 0.51, I can work backwards using inverse trig to find the measure of that angle. Into the calculator, I'm going to press second, then the cosine. Notice that it says cosine -1, which means inverse cosine of 0.51. Press enter. Now you want to round this off to the nearest whole degree. So what would we call this, Mr. Stern?
59 degrees.
Perfect. Let's do one more together. We want to find the measure of angle A if its sine is 0.829. I'm going to press second, then sine, and then 0.829. Enter. What would you call that, Mr. Stern?
56 degrees.
Yes, to the nearest whole degree, let's call that 56 degrees. All right, class, I'd like you to press pause and calculate the measure of angle A for both of the next two problems. Press pause. All right, Mr. Stern, what should they have gotten?
57 degrees.
Okay, and for the next one? Let's see, what are we going to get for the next one? 1.14 degrees. That's very tiny, so let's just call that 1 degree. All right, so that's just basically how to use your calculator, but these aren't the types of problems we're going to spend the most of our time solving. Well, before we can get into the types of problems we're going to spend most of our time on, we need to learn a bit of vocabulary. So imagine we have a building, okay, and that building has a height. And because the building's going to stand straight up, we know that this is going to be a right angle. Now, this distance on this side would be the same, and we end up making a rectangle. We know that in our rectangle that the opposite sides are the same. And if somebody was standing on top of our building over here, and they were looking down, if they were looking straight across, they would see to the other side and their head would be, this is hard to explain without you guys being in front of us, but if they started to look down, the amount of degrees that their head moved would be perhaps the angle of depression if they were looking from here to here. Conversely, if we had somebody standing down here and they were looking up to the top of the building, their line of sight would start off level and go up at an angle of elevation. Mr. Stern, do you think the angle of depression and the angle of elevation are related?
They're congruent.
Yeah, well, we have to know that these are going to be parallel lines. So what type of angles are these?
Alternate interior angles.
Perfect. So if we know that the angle of depression is, we'll say, alpha degrees, what is this angle inside here?
90 minus alpha.
Great. And depending on your diagram, it's sometimes necessary to subtract the angle of depression to make it in your triangle. Although we know that this side and this side are the same, so you could just reverse your triangle. Doesn't make a lot of sense now, but let's do a couple examples and then you'll see. Alright, let's do this first sample problem. At a point 166 meters from the base of the Sears Tower in Chicago, the angle of elevation to the top is 68 degrees. To the nearest meter, what is the height of the Sears Tower? Mr. Stern, are we looking for a leg of the triangle or the hypotenuse of the triangle?
We're looking for the leg.
You're correct. So this is the height of the Sears Tower. We're not looking for a hypotenuse. Well, we know so, ka, to, and I know that so and ka, or sine and cosine, both involve a hypotenuse, so it makes it really easy to choose which trig function. We're going to use what?
Tangent.
Great. Now we always take the tangent, or any trig function, of the angle. So right off the bat, the angle goes next to the trig function. Now tangent is equal to opposite over adjacent. What are you going to fill in?
X over 166.
Good. Now we need to complete our proportion. I like to leave it in terms of tangent till the end. So if I need to solve for x, I would multiply each side by 166. That means x would equal 166 times the tangent of 68 degrees. So I'm going to go to my calculator and enter 166. And I don't even need to press the times symbol on my calculator. I can then hit tan 68. When I do that, I get 410.86. And the problem does say to the nearest meter, so what should I round that to?
411.
Great. So now we can say that x is 411 meters. So to recap, we know we were given this angle And I kind of asked myself, relative to that angle, what two sides do I have? I had the opposite side and I had the adjacent side. That told me it was tangent. I always take the tangent of the angle, I set my proportion, and I solved for x. Well, what do you think of this trig stuff, Mr. Stern?
It reminds me of a story, actually.
Really, a story?
Yes.
I think we need a visual image.
There's a small island in the Pacific Ocean, and there was a great king who had a beautiful young daughter, and he wanted to find the right suitor for his daughter. Thousands of men across the island applied to be the suitor, but the king wanted the wisest one of them all. So on this island, there was a mountain, the mountain of truth, and atop this mountain was a special sacred tree, and the king never knew how tall this tree was.
Well, couldn't he have just climbed the tree?
It was very hard, so the problem that he posed to the potential suitors was this. Whoever could determine the height of the tree from the ground, not from the mountain, but from the ground, he would let them marry his daughter.
Wow. What was his daughter's name?
His daughter's name? Wolverina.
Wolverina. What was his name?
I don't remember. And so many of the suitors got their mountain packs together, got their rope, and they started to climb. But there was one suitor who had a bright idea. He thought to himself, couldn't I have a right triangle? Couldn't I use trigonometry to determine the height of this tree? And he became the next prince.
Ah, well, I think that's a really great story, Mr. Stern. It reminds us that we can use trigonometry to find the measures of really important things. And those lengths can impact our life.
Absolutely.
All right.
Should we try some more problems?
I think so. All right, let's look at page 49. And let's start with the first one.
A radio transmission tower is 83 meters high. A support wire is attached to the tower 25 meters from the top. If the support wire and the ground form an angle of 42 degrees, what is the length of the support wire?
So I just marked the support wire in green, and we were told that this angle was 42. And what are we trying to find here? Looks like
What is the length of the support wire? So the hypotenuse.
We're trying to find the hypotenuse. Well, we need a side of our triangle. Mr. Stern, how could I use these two lengths to generate the side of my triangle?
Subtraction.
I agree. So let's go 83 minus 25. And what do we get?
We get 58.
Therefore, the length from here to here is 58 meters. Now, relative to our 42 degree angle, what two sides do we have?
We have the opposite and the hypotenuse.
So that would be...
That would be opposite over hypotenuse. That is sine.
Good. So let's take the sine of 42 degrees and set that equal to the side opposite, which is 58, over hypotenuse x. Now, there's a couple things you could do to solve a problem where the x is in the denominator. You can always treat this as a proportion and cross multiply. So if I were to do it that way, I would have sine 42 times x equals 58. Now I would divide each side by the sine of 42. And I would get that x equals 58 divided by the sine of 42. Now, notice what happened back in our original problem, that the sine 42 and the x just exchanged places. So if you'd like to just remember that, that'll make solving these problems really easy. So let's go to our calculator. I know I have to have 58 on top divided by the sine of 42. Enter. And we get 86.67, and it said to round to the nearest tenth. So Mr. Stern, what do you think that is?
86.7.
Nice. Now you can, at this juncture, get a value for sine 42. But if you're going to do that, I would be sure to not round to the nearest tenth at this point. I would do at least to the hundredth, if not the thousandth. Okay. Let's continue. Number 2, how far below the sea level will a porpoise be if it swims 250 meters at an angle of 12 degrees of depression? So relative to our 12-degree angle, what two sides do we have?
We have the opposite and the hypotenuse, so we should use sine.
Nice. Sine of 12 degrees equals
X over 250.
Nice. We don't have the x in the denominator, so we can just multiply each side by 250. X is 250 sine 12. Go to your calculator. Hit 250 sine 12. Enter. 51.97. What happens when we round this to the nearest tenth?
52
Exactly. X equals 52.
meters.
Oops, I put degrees. Thank you. Alright class, what I'd like you to do is press pause and attempt to do 3, 4, and 5 by yourself. Press pause. Alright, so let's see how you did on number 3. If a plane flies off course, 1 degree off course for 6,000 kilometers, how far away will the plane be from the correct path? So we already have a nicely labeled diagram. Relative to our 1 degree angle, which trig function do we have?
Opposite over hypotenuse, so use sine.
Wow, I see a trend here. Sine of 1 equals x over 6,000.
Multiply 6,000 by both sides.
So 6,000 times the sine of 1, and I get
104.7
great.
kilometers.
Yes, units are important in this unit. Alright, now how high is the cliff? It's already set up for us. Notice we're not involving the hypotenuse, so it pretty much gives it away. We're going to use tangent. Tan of 37 equals opposite x over 300. We can multiply each side by 300. 300 tan of 37. Enter. 266.1.
226.
Oh, I have it right there. And look, I said 266. I must have a long day. 226.7 meters. All right, let's see how you guys did on number 5. How far is the boy from the monument? So he is looking up to the top of the monument at an angle of
65 degrees.
And that's an angle of elevation. Good. So we could say that the tangent of 65 equals opposite over adjacent. Here's one where you have to remember the trick, or just cross multiply and divide. And you get that x is the same as 150 divided by tan 65. 150 divided by tan 65. Oops, I forgot my tan. Let's go back here. Tan. Oh no, let's just clear and start over. 150 divide tan 65. Enter, and we get 69.9. Alright class, good work.